Hello, can
Oh,
you hear
sorry.
me?
Yes, I'm sorry actually. I didn't know actually what time I'd reach,
It's okay, don't worry about it.
and then I got a little early than expected. Late, but a little early. Okay.
That's
So,
okay.
what you have been doing? Do you want to share the screen and show me
Yeah.
what's that?
Um, yeah, I'm joining really quickly with I'm having issues joining on the computer. Actually, I know what to do. Give me 1 minute. But
So
I've been
today, I think we can just meet like half an hour.
yeah, that's okay.
Yeah.
I've been doing the example that you told me to do.
Yeah.
I
Can
I
you?
just finished it and I was able to output something.
Oh, that's good. So let me see. If you share the screen, let me go through the input so I
Okay.
can tell a few things.
Mm, Okay. All right. So
Are you
this
sharing the screen?
is, yeah, right here.
Okay.
Okay. So this is my input files. Um,
Okay,
I'll
so
just go through,
let's go through that input file. Let's go to
yeah,
general. General.
general.
So you see in a default is precision, that's good. What's
Yeah.
the beam? Let's look at the beam. Show that card. Now you can go in, yeah, okay. Now you can go to general back again. Just
Oh,
click that and then show cards.
oh.
Did something happen?
Can you see it?
Oh yeah. So it's
Okay.
270 GeV Me1,
Yeah.
negative Me1.
Mhm.
Where do you start it from? You starting from 10 meters?
Um, 10 meters away. I think this one was 50 centimeters away. I just copied the thing, but I could easily change that. You
Okay,
said
so
10 meters?
let me see again just once. Uh, so from Fluka, if you are throwing the Me1 positive to negative, up to down,
Mm-hmm.
make that type negative and note that somewhere. Now, not here,
This is
but
the beam right here. This is what it looks like
oh, okay.
50 meters
Oh, okay. Is
or
it going
50
to?
centimeters. Yeah, it's
Okay.
going through the argon.
Oh, okay. So let's go back just once. I want to make sure. So can you change that negative?
Yeah, I think it'll point the other direction. Yeah.
Oh, okay. So, I don't know why.
Yeah, it's weird.
Okay, so it depends on the orientation. It should be fine for now. Okay. So you have the reason that is black hole. That's
Yeah,
basically
around it.
very large, right?
Yeah,
Where's black hole?
right here.
Why
I
is
used the uh I used the example file as black hole
so why is black hole outside that?
outside the vacuum.
Yeah, so if we go back to the input,
Here, this one's the black hole.
so let me tell you one thing. Uh, do you know why we use black hole? Because if you
Yeah,
are,
so
yeah, you go ahead.
when a particle goes into it, it kills it.
Yeah, so basically we do not want to track particle outside where we are interested in because we are just losing computation resources.
Yeah, so I
So
see.
in your case, you define the geometry well, but that region definition is not proper
Right here.
because, yeah, so because Your black hole is outside because you subtracted body one minus body two.
Yeah.
What if you do body one minus body two minus body three minus body four minus body five?
Um, it won't do anything.
Can you do that right now?
Okay. Sorry. I'll just keep that because that's the plan. Okay.
With the black hole again.
Here. It looks,
Again, it is outside.
yeah.
Why is it outside? Because it should surround that volume.
Yeah.
Let's go back again.
Okay.
Let me go through that definition, okay? Then you have body two, that is vacuum.
Yeah. Body three is the argon. Body four is the air. And body five is the rock.
Why did you add body three plus body six?
Or, oh, sorry. That was my alarm.
Yeah, I think your
Body six is the, okay, so I wanted to know the body six is the plane. So I wanted to split the region of argon so I could trap the particle fluence through it.
okay. So
Okay.
that's also actually each region should be uniquely defined. So we have to change quite a lot in this because it will not work. So
Oh,
let's
yeah,
start.
okay.
Let's start from very basic thing. Let's make it logical.
Okay.
So usually when you define various regions by basically some logical addition or subtraction of bodies, you know, the best place to start is from something very inside.
Mm.
What is the innermost volume
The argon.
organ? Okay, so I would suggest let's not split that because it's one level up, you'll understand that later.
Okay.
Because
So
we
do you
have
want me
to.
to just delete the liquid argon or the plane?
Yeah,
Okay.
I want to make it simple so it makes it easy to debug. Or you can deactivate for now.
There we go. Okay. I'll just get rid of body six.
Okay, so now let's think about this from a region perspective first, and then we will go back and look at okay, can we go? Okay, yeah. So the innermost volume, I would like it to be argon, and argon is surrounded by what in our case?
The air.
Air. Outside air, we have rock,
Yeah. 5 meters air, 5 meters of rock.
and then we have black hole, right?
Yeah. Oh, 3 meters of air. Sorry. And then vacuum out again, and then black hole.
Okay, so now we'll try to get this thing from inside out, from region perspective.
Mhm.
So you see that body five,
Yeah.
body four, and body five both are argon.
No, body three is argon. I can rename it.
No, it's okay, it's okay.
Body three is argon. Body four is the air, and body five is the rock.
Okay, so we have just one argon right now.
Yeah, just one body of argon.
So in that case, let's make upper one more logical. So let's start from body one. I would say don't keep name. Let's change the name body one into black hole
Yeah.
and maybe BD, BH. Yeah. No, because it does not. Yeah, black hole one. That
Oh, I
is.
don't know why that.
No, it should be fine.
Yeah.
Then what would be the next vacuum?
Yeah.
V, yeah, vacuum Y2. Oh, okay, it should be fine. And then what's that?
The argon,
Yeah. Liquid argon 3, right? And then what's that?
the air,
There.
AI one, or AI one. And this one is, I don't know why I did that. Okay. And then um, GR five.
What is that? A rock?
Yeah, Grand Sasso Rock.
Oh, okay.
I took it from the Dark Side 20K.
Okay. So let's go back to black hole. So you
Mhm.
define a black hole that's of that length, that breadth, that height. So black hole is as big as you can. That's good. But I still making it's making it so difficult to actually look at the plot. So can you make it like 50,000? That should be more than enough for us.
Okay. 50,000. Like
Yeah,
that?
yeah.
Okay.
You know why I wanted you to make that? Because it's good to actually see everything in the same plot without zooming in.
Mm, okay.
Because 50,000 is 500 meters.
Oh, wait,
With
should I make this one, should it be 200, 50,000, 25,000
no, it's
and
really
then
fine.
25?
Yeah,
Okay.
I just give you the idea. You can change it later on, but make 50,000 for now. It's
Okay.
just
So it's 100,000 wide.
yeah. So if it is 50,000, then let's make it in a 5,000 for
This
vacuum
one? Okay.
because 5,000 is also quite a lot. 50
That's
meters.
50 meters. Okay. Oh, okay. I see what you're doing. And you're teaching me good habits for from scratch. Yeah. This one. I'll recenter this one.
Yeah, Jermaine will think about that. That's also fine. 5,000. Good.
Okay.
Now let's go to liquid argon. So what's the length, breadth, and height you want to put that liquid argon?
5 meters by 5 meters by 5 meters.
Okay. So in that case, minus 250 plus 250 minus 2, that's good. Now I wanted to say, let's make Z mean because liquid argon is our center, right?
Yeah. Oh, I need to change this one because I just moved everything. Here we go. Because I shifted everything to the right, so
Now let's think about this. So liquid argon is in a center 5 into 5 into 5. And then what does it? It is surrounded by what? Air,
3 meters. Yeah, 3 meters thick of air.
3 meters of air.
11 meter cube of air,
Okay.
basically. An
So
11-meter shell.
let's move the cards around because after a black hole, we have vacuum, then it's good to have rock in there.
Oh, I see. Okay. So it's like from biggest to smallest.
Yeah, because it's enclosing. So yeah, we can change that later on. Now move that
Oh,
in a
sorry. Um, okay. So, ooh, I don't know what just happened. I think
so
I accidentally deleted the.
no, it's okay. You can take time. So one thing I wanted to say is it's easier to it's better to actually cut and paste
Yeah.
or
Okay.
because you're moving too many things around.
Yeah. I'll add the black hole. I'll add the rock later.
Control Z does not work. Maybe it works.
Control G. Um,
No?
yeah, I don't know what happened to.
Yeah. When you're using a Fluka interface, you have to be very careful because sometimes you put things on and
Yeah,
okay.
you could accidentally click on something.
Okay, so let me tell you one thing. I'll actually make it much simpler. Uh,
Okay.
okay, so Actually, let's build the rock be above that liquid argon. Can you delete that card?
I'll try to move it.
Okay.
Okay, I guess. I guess
Yeah, I like actually cutting and pasting.
okay. Okay, okay. Yeah.
What was the rock length? 5 meter thick?
Um, yeah, 5 meter thick. Let me see what I have it written down. I think it was 21. So 21. Oh wait, no. Um, I think yeah, it should have been 21 by 21 by 21. I made a diagram here.
Okay.
So it's just 21.
If it's
So it
21,
should
then
be
20
10.5.
actually. Yeah, we can minus 10,000, right?
Yeah,
Yeah, we minus 5,000, sorry, minus 1,000 or 10,000. Okay, 10,500. Okay.
10,500.
Yes.
Okay.
Now move that air up.
Let me look at the rest. Because move it up. Oh, I think I accidentally deleted the region data. Oh, this error. Okay, I see what you mean. Sorry. Sorry.
Yeah.
Put it above right here. Okay,
Okay.
so we have the biggest to smallest.
Yeah, it's building geometry. That's a in a very difficult part. So it's fine. Yeah, it's a kind of a learning curve for you. So let's go back actually because I like actually reasoning there. Let's go back.
Okay.
So you have a black hole, then a vacuum, and then so what? So vacuum we have to make it larger now, right? Because it is okay. So
Oh, yeah.
No, sorry, Grand Chateau Rock, you made it like 105 meters. Let's make it 10.5. That's what you intended, right?
Yeah, 10.5 by plus 10, so
Yeah.
21,000.
So remove 1 0 there for Grand Chateau
Oh, make it smaller? Okay.
because 10,500 is 100.
Oh, no, yeah, yeah. I think I accidentally added another zero there. There we go.
And then that's air.
Yeah,
uh,
I think the air is correct. 11, 11 meters wide.
hmm. So now let's define liquid argon first
Okay.
in the region.
Uh, yeah. Yeah, I'll just make this one bigger.
Yeah. Now, Fluka does not take more than 7 later in
Oh,
there.
yeah. Um,
Yeah, you
I
can
don't know
write
what
it.
to name it.
Maybe you can write R. I like R because it says reason, right? Sometimes body and region.
Oh,
R and then maybe liquid argon. LAR is better.
yeah.
Yeah. So you see, let's just focus on that liquid argon. Then everything in that body L liquid argon 3 is argon. So it's very simple. Just put
Mhm.
LAR3. That's the body our body name. Just LAR3, right? We built argon.
Yeah.
So we fill it with argon. Let's fill it with argon. Go to assignment.
Okay.
Media. Media. Okay. Now let's go back again. Now let's create another region card.
Okay.
So now
So,
outside liquid argon, we have
okay.
air. So let's write R air or whatever you want to write down.
Okay.
And then obviously air, when you look at that RPPI 5, it encloses, wait, just please wait just
Okay.
once.
Okay. Sorry.
Because let's first reason, because I want you to learn how to reason and make a reason. Because if AI5 is a body, encloses everything inside, even liquid argon body there, right?
Yeah. So we do plus AI5 minus LA3.
Yeah, good. Okay, so now let's make another reason.
Then it's
So
the same
no.
Grand Cecil.
Yeah, so Gran Sasso includes everything, right? Gran Sasso body. Yeah, make
Yeah.
it less than 7 liter, okay?
Um, yeah.
So what would be your reason? First tell me the reason and then we can.
Plus GR Sasso and then minus LAR3 or yeah, minus LAR3 minus a. I don't
Yeah.
think we need to do. Do we have to do AI5 or is it just automatically like taken out because air surrounds the liquid argon?
Cool. Just a moment.
Someone coming.
I don't know. Okay, so let's try. So you mean reason you define is Gran Sasso minus? I forgot actually whether you can define subtract a reason there or not. Can you subtract just minus R air there? Is it allowed? I don't know.
Or you mean? Oh yeah, okay. I see what you mean.
Minus R air. Let's
Oh,
go back. Let's make our
you could
reasoning.
subtract the region?
Yeah, that's just I was thinking maybe if it's not possible.
No,
Yeah,
I
I
don't
see.
think it's possible.
Okay, I see. So in that case, it has to be minus AI5. I think that should work, right? Because AI5 encloses. Okay.
Yeah. Is it okay to just add in case or
Now
minus?
let's try actually because we have to learn. So let's make another reason
Okay.
because I actually. So now we have vacuum too. So make reason vacuum. What would be the logic you'd apply?
Plus vacuum 2 minus your assets.
Okay, so let's make another reason. Look, if it did, this is actually.
Okay, and then this one could be this one.
So just can you click on the left there? You see there? No, let's go back to geometry. So let's click those all of those regions. Where is liquid
This
argon?
one's right here,
Okay,
center.
next,
The air surrounding it,
good.
and Grand Sessa,
Yeah,
and the vacuum, and the
yeah. No, okay, that's excellent. So let's see the errors now in the geometry. There's no error. That's
yeah.
some.
I think there's only errors because we haven't assigned material to it yet. So, but there's
Okay,
no errors in the geometry itself.
okay. So let's go back. So let's assign the material.
Okay. I already have all the material here.
Yeah, so black hole. Yeah, there is black hole. Yeah. Reason.
Oh, change.
Let's wait.
Oh,
So
okay.
black hole now has to be a reason, right? Because that's where actually black hole is.
Yeah.
So you have to use reason there. RBH, is it reason? Can you go
Yeah,
back to
that's the region black.
okay, I just wanted to confirm. Okay, good. Excellent. Now let's save this. Okay. So now, let's go mm, to, transport. Can you show all cars? Right click, show all cars there. Okay, so let's switch everything off because we planned previously that we don't need to want to actually test a lot of things, right? There are only
Yeah.
two things we wanted to test. What were the two things?
Uh, user track and user BDX.
User bin, I think.
Oh,
Yeah,
user bin. Okay. So I'll just turn. Can
yeah,
I delete this one?
yeah. Don't delete, you can deactivate.
You can
Disable card,
deactivate it?
disable card.
Oh, I didn't know you could do that. Oh, okay,
Oh,
wait. Oops.
you selected number of cards, so it disabled all. Okay, just okay. Disable that.
I'll just keep one user track.
Yeah.
Mm, one of them does fluence. Oh, no.
Okay.
Since now there's one, we only need one. So this one should be region. We would put our bin.
Actually, let's do one thing.
Okay.
Let's have only two user track card and two user bin card.
Okay.
And let's record the neutrons in rock as well.
Oh, okay. So Grand Cecil.
And let's record user bin in rock as well.
Okay.
Actually, user bin is not region dependent. You can do for all length, right?
Yeah.
So one card is enough. We can look at the neutron flux. So where does
On
it
the
start?
entire
Yeah, I want
uh
to start. Do you know where does rock starts?
yeah,
Let's go back.
negative.
Let's go back to the geometry.
I was
Oh,
I
okay.
think it was this.
Okay, good. So it records everything actually, right? Newton
Yeah.
flux. So there are a couple of things I need to tell you.
Okay.
One, you see the user track name their card, NE Fluent U, the name you gave
Oh,
there.
right here. Yeah.
Yeah, so I like it has, I think, 8 letters, right?
Yeah.
Yeah, when you give name, just use 7 letters.
Okay.
So you can do something like NR, right? NR, yeah, fluence or something like that. N would be neutron, R would be rock. Yeah, something like that. That
Oh,
would be
this one's the rock. Yeah,
uh,
okay. And then this one was N uh A flu.
yeah. Then let's go to user bin. User bin does not record energy deposit at this point. It does just records flux. So let's change that name. Something like N N total.
Uh
Tot- So let me tell you one difference. We have talked about that before. User track gives the energy distribution of the particle you are interested in that region.
yeah.
So you get energy spectrum. User bean does not care about the region in this case at least, because that's where the way it's defined. It only
Mhm.
cares about the flux at each point, at each x, along x, along y, or along z.
I
So
see.
basically it integrates the fluence over energy. Once you integrate
Mm.
over energy, you get just counts. So user bean just gives us counts. It doesn't give energy spectrum. You got the idea what I mean?
Yeah.
Now let's do something mm, can we save this?
Yeah.
And then let's compile once how it goes.
Okay. So sorry.
So let's remove that Megre and Soda because we have not used that. Leave that
Okay.
because it does not do anything because it's default one. It gives you nothing. But
Yeah.
when we leave that, we'll start using. So usually it's good to clean first. Let's again do that because it says you see all files are up to date. So clean the earlier compilation, clean the executable you created with earlier compilation, and then just build it.
Mhm.
Did it build successfully? Excellent.
Yeah.
Let's make a run. Before that, let me tell you one thing. Let's go to the input file.
Okay.
So if we go to general, when I generally run the simulation, I like to have control over that because it should be reproducible. So instead of using Fluke as own random seed that I do not know, I like to put my own random seed so I
Okay.
can replicate that. So you can put any seed that you like. It should be a number.
Oh. The date today is 01/26.
You save this. Yeah, actually save the input as well. I like you save the, but yeah, in example, you can name something else. Example, whatever you want, give more informative one actually. I like,
Okay.
giving, me one in liquid argon or something like that. Even mono energy, 270 GeV me one in liquid argon. That's better actually, right?
Mhm.
It's just kind of a practice I'm teaching actually.
Yeah. Yeah. Good
It-
habits.
It's easy to forget because once you start changing things, I think it's good to actually make copy of another input file again because it's hard to go back. Now let's, we did the compilation. So compilation is independent run. Let's do just one run for now, not 5 cycles, just one cycle.
I think let me check how many runs there are. There's a
There are
thousand in
1,000
this one.
events. That's really fine.
Okay. Clean.
Yes, that's good. Refresh.
Oh wait, I just realized we need the beam. The beam. The beam is not in the right position. Where should I put the beam? 1 meter away? 10 meters away?
Maybe somewhere in vacuum, that would be good.
Okay, I'll put it 2000 right here. Like right
Yeah,
here.
minus 2000 and then going along positive direction. Yeah, this is something I want to tell you again. Let's go back actually. Look
Okay.
at that.
Wait.
So it's easy to identify there. Look, your Z along, right is increasing.
Mhm.
You see there?
Yeah. Positive,
Look at
negative.
the Z axis. It's increasing,
Yeah.
right?
Hmm.
And if you want to fire from negative, say minus 2000, what would be the direction, positive or negative?
Positive.
Yes, so that's what I actually wanted. I didn't understand how you put your beam earlier, but I like this because now you see you are starting at minus 2000 position, and then your
Mhm.
beam is going along positive direction.
Yeah.
So let's go
I'll
back
save.
and look at the input again.
Oh,
Minus 2000 and positive.
oops.
That looks, you see there?
Yeah.
So that I like it because this may, or you could start from another place as well because it's symmetrical. But I like this because it tells you it gives you, it is informative, you know, which your direction is. So let's
Yeah.
run a clean. Okay, good. So sometimes if it takes time, it's good to refresh. Can you do refresh? You see the refresh? Finished. Okay. So it finished so early. There must be some problem. Let's do go viewer. Load. Let's look at the log file first.
Oh, wait. I don't know. Wait, hold on. These were the other examples that I ran, but
Yeah, if you go down, there must be somewhere there.
yeah, right here.
Let's look at liquid organ log.
Yeah, there was an error.
Okay, so let's look at the log file first because it's a good, you know, thing to look at. Because if it's serious error, it comes in log.
Here.
Yeah. Can you go down? So there is no error in compilation. So there is no serious, you know, stop. No material assigned to a region. You see there, the
Oh,
bottom. Now let's
yeah.
look at the output file. Dot out. So you see region 2 error has no assigned material. Let's look at the error file. We know the problem, but I just wanted you to actually, no, dot error file.
Oh, okay. Well, yeah, right here.
Yeah. Stop, no material. Basically, region 2 has not been assigned any material.
Okay.
Okay, so
So
let's
these
go
are all
back.
the places I can spot the error.
Yeah. So let's go back to the, you know, input. Let's go to the media assignment. So let's look at, you know, what is RAR? What is the standard?
Um, yeah, I see right here, right there.
Save the input file first. Save input file. Good. Then, you know, you can save Flare as well if you are interested.
Then run
Now
clean.
let's clean that. Compilation went well, so we don't need to compile again. Let's start. So I had a discussion with, you know, Dr. Sean
Yeah,
last week over email thread. We had
yeah.
some discussion, you know, so the discussion is still ongoing. But I'm actually, you know, interested since I'm not the member of Dark Side. I next week, you know, I'll actually, you know, tell you an email. Basically, I'll tell you a few sentences that, you know. So our plan, you know, initially right now is actually use music code to generate me-ones for Dark Side.
Music board.
Yeah, and that music code was developed by Vitali, you know, Professor Vitali from UK.
Can you
So I
spell Miji code in the chat?
so MUSIC, music code.
MUSIC.
Yeah, so basically music or muson, that's what they call.
Ah, okay.
Professor Vitali from, I think, University of Durham, UK. So this code is not open source.
I see.
So you have to personally ask with him. So we'll make an email next time. And actually, I want you to, you know, write an email to him to ask for that code because I do
Okay,
have the code, but it's not good to actually distribute that because it's good to ask from the author himself.
I see.
But in addition of asking code, I want to ask whether, you know, music has ever been used at Grand Sasso, you know, to actually generate muons. That's the first
Okay.
question. Has, you know, this code ever been used, you know, to generate, you know, that's the first question. Second question, music has been used quite a lot for flat overburden. That's
Mhm.
something to keep in mind. But Grand Sasso,
Over flat over.
Flat
Burden?
overburden is basically rock overburden. Rock is flat.
Mm,
It's snow lab. It in a various underground sites, right? So
yeah.
music has been easily used. I know that. But we need also to ask how easy it is to use music for non-flat overburden like Grand Sasso, because we have a mountain overburden there that's not flat.
Yeah.
So that's another question we need to ask. And then another third question is, has someone from the literature I see, someone has written C++ code, because music code is in Fortran, and if it's C++ code is available, then it would make it easy for us. So is there a C++ version of the code? So that's another question.
Okay.
And fourth question, previously, we used Anton Empel's work, who propagated overground muons all the way through to Grand Sasso Rock. But we are planning to use music to do that. How easy it
Can you
is.
can you repeat that?
So previously we used, Anton Empel's work where he propagated the muons through the Grand Sasso Mountain. I think with music, we can do it easily without transporting muons.
Okay.
Without, because when you use Zen for Fluka, you have to allow the particle to interact. But music actually calculates, so it makes it easy. We don't need to waste computational resources.
Okay.
So I just wanted you to think about this, and because we'll write down this email together, because I do not want to write down, because I'm not the dark side members.
Mhm.
But it's good for you to actually write down. It's good in a place to actually start in a relation with people.
Okay.
And then just ask, once we make an email, ask Son Westerdale if you can CC him as well, because it's good. It gives more credibility. So we'll make
Okay.
that next week. And then before that, I want you to actually just go through that, because this is something I would say I could write down easily, but I do not work for Dark Side or any experiment at Grand Sasso. So it would be actually good for you to write down. So that's what I thought.
Okay. Yeah, I can definitely do that.
Yeah, but let's write it together. I just want to make sure that you know you are actually writing it properly, because he must be very busy. So if we get all answers in one email, then that would be great.
Okay.
So this is just our query actually. You understand what I mean?
Yeah.
So we'll write down email together. So we'll build it. But just I want you to think, and then just go through this paper from Vitally, what music does for your own,
Okay.
I shared it within in chat, the paper name and the professor's name.
Okay.
Because when I talked with Son Westerdahl, he actually was convinced that maybe we could use something different. It is hard to replicate Anton Empel's work, because you have to waste a lot of computation resources for transporting muons all the way through the Grand Sasso Mountain, that maybe 1 kilometer height, I don't know.
Yeah.
So one last thing before we actually, I want to actually stop here, because I have a meeting in 5 minutes.
Okay.
And what I want to do is, I want you to go, let's not, let's look at the output file just once, just once, just output file, load, load.
Sorry. Um,
Oh, okay. You know how
oh,
to, you can remove that all, yeah. Load,
yeah.
load,
Uh,
and then where the output file dot out. Is there error at the end?
no.
No, it's excellent. Now my idea is, you basically got this thing done very nicely. So one other thing that before we meet you can do is understand Ron's summary, because there is where the physics is.
I
How
see.
muons, how muons, lose energy. So, learn about, run summary, learn this, just go through that because there are a lot of particles produced here. It's a very energetic collision. Learn
Yeah.
about what is inelastic secondary there, what is low energy Newton there. Just go through that, just I'll give you just some summary next time, but I want you to actually, do that. And you'll answer me one question. For that 270 GeV Me1, what is the percentage of the Me1 that pass through our setup? So I don't want to, just tell me this number by understanding the, you know, understand that run output. How much energy, what fraction you can write down in percent.
Mhm.
What percent of Me1 energy loss was by ionization, and what percent in electromagnetic and hadronic showers? So these are the two questions you'll try to find the answer to based on the run summary. And
Got it.
let's go back to the run because I want to end this in a, let me send an email. Okay, 4:30 sure. Uh, Actually, I have a meeting, but I just wanted to move that meeting.
I have a question.
So yeah, you have a question, yeah.
Sean said that he was thinking of adding another student to
Yeah.
the project, but I personally don't want another student. But I just wanted to know your opinion on that.
Yeah, actually, I had already discussion with that. So, actually, I think, based on what we are planning to do, it's actually basically too much work for you. So, you understand what I mean? So,
So
you
you're
likely
saying get
grad
another.
you likely graduate next year, right? So
Yeah,
we have 1 year. So I'm not sure how many hours you will be able to spend on this in average. How many hours a week?
I spend 12 hours a week.
Yeah, so with 12 hours a week, and since Fluka is a big learning curve, and what you are trying to do is physics heavy, you also need to make sure that you understand what you are doing, right? So learning and then being exported Fluka and then delivering something that could go into a paper. Actually, I think 1 year is not enough.
Mm,
So what, from the discussion I had with, Dr. Son, it's good to have two Fluka people who do two different things, and we can combine together to make a beautiful paper.
okay. All right.
So
I'll tell Sean about that then.
yeah, so I think whatever you'll do, I think it will be more for Grand Chasso.
I see.
But likely whatever another guy would do would be for Surf Dune. Where is Dune located? Another place, another thing. So basically, it's good to have that. So I actually personally like that because if there are two people, I think we can produce a very quality paper because I won't be able to work on this at all, but I can
Yeah.
guide. But it's you who will be, working on this. So, 12 hours a week, I think, I think personally it's good for you to have a beautiful paper sent to archive or journal in any year time.
Okay. I understand.
So most
Um,
likely, you and other guy will be author, and maybe Dr. Son, and maybe I'll be author as well. So basically, so let's imagine one paper in an year time where there
yeah.
will be like 4 or 5 people of us, and we'll deliver something very important from, we'll extract something very important for Fluka, from Fluka that will be useful to the community, and dark side will use that result for another 10 years. So that's our plan.
All right.
Now,
Sounds very good.
now you
Sounds
can
awesome.
understand the impact, right?
Yeah.
So it's actually good because I know, because Fluka is tough. Even, Tina and Iptika, when they were working together, they were finding it tough. But this whole thing, actually, I did it all alone. So I have the experience of all this. But they did very good. They went one step forward and then they developed a script to actually get the Fluka output properly. So we have already one step ahead than where I was. like in a 3, 4
Okay.
years. So I'd say, it's good for you and then, for him as well. Him or her, whoever joins.
Yeah.
And it's easy to actually divide I have a plan for you. So I have, talked to Dr. Son. I have a plan for you, what you can get and, to get a beautiful paper out for an undergraduate. It's good. And
Okay.
so there's
Sounds
so
very
many
good.
work, so many things we can do with Fluka. And I have actually, sent like 2 pages full of email that we could do with Fluka. And so, we can always divide and then still, we can find people to work on. You
Okay.
understand what I mean?
Yeah, I understand now.
Yeah,
Before I didn't want another student, but now I'm open to it because you're
yeah, I
saying
think,
so.
we can actually develop 2 or 3 papers. And even if you go away, we'll find another student and then they will publish the paper based on your results. So you'll be in that paper for like another 5 years. So that's another powerful thing for an undergraduate. You understand what I mean?
Yeah. Yeah.
So all
Okay.
Fluker papers, you'll have your names on it. So it's actually good for an undergraduate student that, in building career. So I'm thinking, maybe we can have 3 or 4 papers in next 2, 3 years.
Okay.
But everything will be built on what you do,
I got it.
and what another guy will do. So basically, it's like, bringing series of papers. You like my plan, right?
Yeah, I like your plan.
Yeah, that's what I actually conveyed when I actually discussed things over in an email with Dr. Son. Because there's a lot of work. Someone needs to know music. Someone needs to know Fluka. Someone needs to make background estimate. Someone need to generate that for in a Grand Sasso as well as SARF. Someone can, work on how hadronic showers are generated, how isotope are generated. So there are a lot of works actually.
Yeah.
So let's go to the data. Let's go back to
Yep.
run
Oh, okay.
and then go to data.
Data.
So, you see these, just wait again, don't click anything. You see, we choose to score something, right? We
Yeah.
want to score neutron energy spectrum in rock and in liquid argon, and then also in a neutron flux all the way.
Yeah.
I really miss Me1. We should have placed Me1 user track as well. So that's something you should use. I want to see the Me1 spectrum as well as in liquid argon.
Okay.
Oh, okay. Actually, we don't need to do that. Sorry. Because in this case, we are using 270 GeV muon. It is monoenergetic. There is nothing interesting about that. But if we use full muon energy spectrum, then we would see the same. So that would be interesting, right?
Mm.
So
Yeah.
that was the part. For now, it's okay. So let's choose just one at a time. Can you go up? Actually, I like, clicking that up one. Okay, just one. Then process, because I don't want to process all these things in a single file. Process, you see the process?
Oh, I see.
Let's do another process. So now let's go back to the viewer. So I have a couple of minutes left. I'm sorry, actually. But you like
It's
it, right?
okay. I can do this on my own time too.
Yeah, so
Maybe.
if you see there is some list and tab list. Let's look at one some list.
Some list.
Maybe liquid organ one. I don't, yeah, let's look that. So you see,
Oh, it's the same. Yeah.
yeah, you see this file?
Mhm.
So next week, I'll teach you how to interpret these numbers.
You told me this one before.
Yeah, but simply if you look at this, you see the total response? Basically, these many neutrons were scored 1.8 into 10 to the power minus 7. You see?
Yeah.
Where do you see that number? You see the total response first, because that file, the rest is actually useless. 1.8 into 10 power minus 7, right?
Yeah.
4 centimeter square for primary. So you have a fluence. If you normalize it properly, you get the flux. So it's such a powerful thing we did just right now.
Mm.
So this is the way we'd validate. Because 270 GeV is simple, monoenergetic. We'll get the Newton flux and compare it with Grand Sasso's Newton flux that people have done. So that's something we'll do next week. You understand what I mean?
Yeah.
But one thing
Well,
you have
we'll
to
do this.
be careful. When you use user track, you have to make sure that your volume is correct. If your volume is wrong, then that answer is not trustable.
I
So
understand.
when you use user track, your volume, if you are scoring user track in argon, you should use argon volume. If you are scoring user track in you know, rock, you should use rock volume. So you have to calculate rock volume. I'm not sure whether you have calculated that rock value.
I can do that.
Okay. So I was a little in a hurry, so I rushed into things. I'm sorry about that. But let's do
It's
one
okay.
thing. Let's
Okay.
let's save this input file, because it's working. It gives us reliable input. So let's save it somewhere else, you know, for all of us, because this would be the way we'll test, in the future as well.
I'll move it somewhere else. I'll move it.
And then we can start changing things. You understand what I mean? So this is the simplest
Yeah.
script that we can always use to validate. If you want to score something, we'll use this script again. Okay.
Okay.
So that's something, you can even give a date to it. I suggest, giving date to it is always good.
Okay.
Yeah, somewhere in cloud as well. Even if your computer goes away, that input file will survive. Okay, thanks,
Okay.
Matt. I was a little late
Thanks,
today, but
Sagar.
we'll meet
It's
again.
okay. Good seeing
Yeah,
you.
yeah. Make sure you are recording, right? Yeah, you can
Yeah,
stop
I'm
recording.
recording.
Record safely. Okay.
Bye bye.
Thanks.
Thank you.
Bye bye. See you.